All right, so in this video series, we are going to be talking about rivets, welding, and we're going to briefly mention bonding. So, rivets. You may be familiar with rivets from what you might find at Home Depot in the tool section or Lowe's. Those are pop rivets. But there's a lot of different types of rivets. Rivets used to be more widely used for structural components. They're commonly used as a permanent fastener, and they're permanent fastener. They're used in bridges, historically used in ships, boilers, and etc. So many other things where you needed a permanent fastener. They can be used as a joint, like a pivot joint or rotary joint for some applications. You might see them on like low-cost toys or things like that. In contrast to bolts, they don't loosen unless they fail, of course, and they can be used, or they are used in, sorry, it's supposed to be in automated assembly. So they have riveters, and they can be used. They are ductile, obviously, and that's because they have to be smashed. They're usually carbon steel, aluminum, or brass. They can be other ductile materials as well. And obviously they can be coated or plated or painted to get them to last longer and be less corrosive if they're used with dissimilar materials. They are not as strong as bolts for the same diameter. And there are many rivets to choose from. Okay, so although it's not an obvious choice for machine design, they are widely used, and there's lots of different options, so you should be aware that they exist. Because of labor costs of using rivets for some structural application, labor costs have driven up the usage of bolts, just because they're a little bit easier to install compared to some of the ways that some of the other rivets were done. This is particularly for the high strength rivets for structures. Rivets require compression to be fixed onto the surfaces that they're being applied on. And usually this is done with a tool, obviously. And the rivets are compressed, but we can say smashed together because We all know what that means. And there's some different types of rivets. The rivet you might have seen like at Home Depot is a blind rivet or a pop rivet, and we'll talk about that in a second. But here are some of the more common rivets, and this is not exhaustive. So common rivets are a solid rivet, and this is the cross section, and in this case these solid rivets were used in structures. You'd heat them up. Sometimes I'd get them red hot in a furnace near where they're doing the construction or assembly. They'd take the red hot rivet, they'd place it between some structure, the hole, and then they would take a hammer, and then they would smash the rivet down, smash it down, and seal the surface. And obviously they're used to seal like two different surfaces, so you might have had maybe like another plate here that the rivets are being smashed on, and they would do the smashing with a hammer or impact hammer or other type of tool to do it. So that would be your solid rivet. Then you have your semi-tubular rivet, where you have some like a hollower section in the middle that's hollowed out. This is the semi-tubular, and sometimes the rivets themselves are used as a piercing agent. So there's different geometries, so they would pierce them and then seal them on the other side. There's the full tubular, which is like the semi-tubular. The tube just goes down deeper. There's the bifurcated split, which is actually here the material's not all the way around, but something like this. That's the bifurcated ED split. Then we have a metal piercing. And this would be like inside, it'd have a divot. And then there's some two-part rivets. We have like a top part, then you have bottom part of the rivet, and then it would go in here, and then you would smash them together, and the compression due to the tight tolerance would hold the rivet in. These are compression rivets. Okay, all these types are mainly used to be like inserted between plates and used as permanent fasteners. And then there's another type of rivet, and this is the rivet that you might see in the hardware section of Home Depot or Lowe's, something like this. And this is a mandrel, and it comes all the way through and has some shape on the bottom, and you would insert this entire thing into something that you're trying to fasten together. And then a tool will come and it'll pull this up, which causes this to move up and then causes the bottom to smash, and then the tool would be right there. The bottom comes out, and usually they have like little notches or some geometry in here, so when you pull it hard enough it'll actually snap off. So you're left with you know, you might be left with like a little bit of a piece here or they design them to where they break off underneath the surface, so you'd have the other part of the top of the mandrel would be there, and you'd have your plates. I guess if we were looking at the cross section, you'd have your plates, and then you'd have this smash part with the mandrel out there like that. And these are blind rivets, but they go by the trade name pop rivets, because when you pull this out and the metal breaks, then it pops. So common ways of using rivets is you'll have material 1, and then you'll have material 2, and then you'll have your hole, and the hole is typically about a 1/16 of an inch larger. And you have your hole, and then you have your rivet. So you'll insert, well, it's a big rivet here. You'll insert the rivet through the hole, and then a common way is to use an impact tool, something that has a divot on the top, kind of like the shape of the bottom of the rivet, and then that will be in, say, like, you know, you have your impact hammer, like some sort of pneumatic tool or whatever, and then you'll hold the rivet in place. Actually, this tool is on the top side, so the hammer is actually used on the top side, and then on the back they might use something like a bar, which has specific shapes and geometry, so you can hold it in different positions, and you'd hold the bar on the back of the rivet here after it goes through, and you'd use the hammer, and you'd basically just use the impact hammer to assemble them, and you can get some really nice looking fastened surfaces using this method. The rivet diameter, D. So the rivet diameter is between, so the diameter is usually between 1.2 times the square root of the thickness, where this would be the plate thickness, T, and 1.4 times the square root of the thickness. So it's typically the rivet diameter. And the holes, the rivet holes, are punched and reamed or drilled. The rivet the holes, the rivet holes are usually about 1/16 of an inch larger than the diameter, which I said earlier. And you have to be careful with rivets because punched holes on larger plates can result in weak spots in the material unless the surface or the surfaces of the holes are treated. And this is mainly a problem for crack propagation, and so you can treat the holes or clean up the holes. You can clean holes by reaming and maybe also annealing to restore the strength. Okay, this is a very broad overview of rivets, but they are widely used. And after the holes are generated, sometimes they're post-processed to make sure that there's that they don't introduce weaknesses by how they have destroyed or torn the surface. So it's something to be aware of. If we take a look at the Machinery's Handbook, they give some guidelines on the design for rivets. Okay, and this is how we do the analysis as well. This is the design for the rivets. It's also related to how we do the analysis when we are doing the design, and this is also how the PE exam questions are written. They want you to have this basic understanding, and these are the design assumptions. And they are that, number one, the load is carried equally by the rivets. And obviously we know this is an assumption because if you don't have exactly the same friction, or you have offset load or whatever, you can have a pretty complex loading situation. So this is an assumption to simplify the analysis. There is an assumption that there's no combined loading or no combined loading or stresses act on a rivet to cause failure. And obviously for the rivet, the primary failure mode is shear. And the third assumption is that the shearing stress is uniform across the cross section in question, or across the cross section of the rivet. Number 4, the load to cause failure in single shear would have to be doubled to cause failure in double shear. Number 5, the bearing stress of the rivet and plate is distributed equally over the projected area of the rivet. And finally, number 6, the tensile stress is uniform in the section of material between rivets. All right, so I'm going to take a look at the failure modes for rivets. And the failure modes for rivets are in single shear. And this is your rivet here. Double shear, where you have 3 plates joined by a rivet. And that's the type of rivet failure, are these 3 types, where you have crushing of the rivet, single shear of the rivet, or double shear of the rivet. And then you have plate failure, which is shearing of the plate, crushing of the plate, tearing of the plate, or tearing between rivets. Now, tearing between rivets, or tearing in general, tends to increase if rivets are too close to the edge. So it's kind of like having a screw at the end of an object. All right, so the codes, there's a couple different codes. So the American Institute of Steel Construction said they specify the loads that can be borne by rivets. They say 20 KSI in tension, 40 KSI in double shear, 32 KSI in single shear. The allowable shear in a rivet is 15 KSI. There's also the ASME boiler code that says the ultimate stress, which is not the design stress, the ultimate stress in tension can be 55 KSI, 44 KSI for shear, 95 KSI for compressive bearing. And usually the design is for 1/5 of these values. And if you look at the machinery handbook, so in the machinery's handbook, they have a whole section on riveted joints and the design stresses that are set by code, how to find out what they are based upon the pitch, rivet diameter, the shear stress, tensile stress, compressive stress. So obviously the shearing of the rivet is related to the shear stress. The resistance to tearing of the plate between the rivets is related to the tensile stress of the plate. The resistance to crushing of the rivet is the compressive stress of the rivet. So this is just some different ways to take a look at the different types of rivets and rivets joints. Okay, so single rivet, lap joint, double rivet, which means there's 2 rows of rivets in the lap joint. Single riveted lap joint with inside cover plate. So here there's an additional plate. Okay, and then this is the cross-sectional side of the 2 plates that are riveted together. And then you have your double riveted lap joint with the inside cover plate. And then you can go on and see different types of joints. So this is a double riveted butt joint. Here the 2 longer sections are butted together in the middle. And then you have the 2 rows of rivets, 1, 2, 1, 2, and that makes up a double riveted butt joint. Triple riveted joint, which means there's 3 rows of rivets on each side, and that's just kind of a quick overview of how rivets are used as fasteners. So in your notes, I've placed some of these, and I also copied an example of how you would do the design for the rivets. We don't have a whole lot of time to go over that, but I wanted to make sure you at least had the example, and that's from the machinery's handbook. Alright, so that is a brief overview of rivets. Rivets are a design option, and they can be a little bit cheaper than other fasteners, and they're widely used, so a good machine designer should be aware that they are an option.